to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile some of the most amazing developments in science and technology, science that affects our life and our view of the universe itself. And today we're going to take a journey to the solar system and beyond. Recently we had this spectacular launch from Florida. NASA is back in the game again. NASA was criticized for many a year being the agency to nowhere. That is, it did send planetary probes out to the distant reaches of the solar system, but it didn't really go anywhere for human beings. And so people thought, well, maybe NASA is rudderless. Well, now, because of SpaceX, we have an influx of new ideas, a new vision, a new purpose for NASA. NASA is no longer the agency to nowhere. In fact, in the coming years, I think we're going to have a traffic jam around the moon. That's right. On one hand, we have the Falcon 9 rocket and the Falcon Heavy pushed by SpaceX and Elon Musk. On the other hand, we have yet another billionaire in the game, and that's the billionaire behind Amazon, Jeff Bezos. And Jeff Bezos has the New Horizon program and the new Armstrong rocket, which apparently can also go to the moon. Not to mention NASA itself. NASA itself, years ago, backed a horse called the SLS booster rocket, and it has the capability of putting our astronauts back on the moon, starting with the year 2024. Write that down on your calendar. 2024, the first men and women will go to the moon. And not to be outdone, the Chinese have set their sights on the moon. The Chinese have the Long March rocket, also capable of going to the moon. Not to mention the Japanese, the Indians. They've all sent unmanned probes to the moon, so there could be a traffic jam around the moon. But today, we're going to talk about the science. The science behind what's in our backyard, the solar system, what's on the moon, what's on Mars, Uranus, Neptune, Europa, and maybe even into deep space. With us today is once again our favorite astronomer, Dr. Ken Croswell of Berkeley, author of a number of great books, including Alchemy of the Heavens, The Search for Meaning in the Milky Way Galaxy. So today we're going to talk about, well, the moon, the Mars, and beyond. What would it be like for our astronauts to once again set foot on another celestial body? So Ken, once again, glad you could be on Science Fantastic.
Glad to be here, Michio.
Okay, first question that a lot of people ask when they see the moon in the sky, they say, where did it come from anyway? It's always been there. The ancients mentioned the moon in their ancient scripts. But what does science say about where did the moon come from?
Well, that's a good question because the moon is actually quite unusual if you look at the many, many moons that we know of in our solar system. If you take all the planets put together, we have something like 200 moons going around the various planets. Only Mercury and Venus, the two planets closest to the sun, have no moons. And the moon is actually one of the largest moons in the entire solar system. There are 7 big moons in our solar system, and the moon ranks number 5 on that list. But the thing about the other 6 big moons is all of them go around giant planets. There are 4 big moons going around the giant planet Jupiter. There's 1 big moon, Titan, going around the giant planet Saturn. And there's 1 big moon going around the giant planet Neptune. Our moon is the only moon, the only big moon, that goes around a small planet. So the question is a very good one that you ask. Where did this big moon come from? And our leading hypothesis is that long ago, shortly after the Earth was born, something really big, probably about the size of Mars, smashed into the Earth, kicked up a lot of debris into Earth orbit, and that debris plus that intruding object conglomerated to form the Earth's moon. So we think that it was a big impact that created the Earth's moon, and that explains how it is that our planet, the only small planet with a big moon, has that big moon.
Now, if it's true that the moon in some sense was blown out of the Earth, then that means that the chemical composition of the minerals of the moon and the Earth are also related, right?
That's right. And in fact, the moon, to some extent, resembles the mantle of the Earth, because when that big impactor kicked up debris, it kicked up debris mostly from the Earth's mantle, and did not kick up debris from the Earth's core, which is made of iron. And so we don't anticipate that the moon has much of an iron core at all. In fact, it may not have a core whatsoever. At the same time, we also believe that much of the composition of the Earth's moon owes itself to that original starting object, the object that hit the Earth. So the object, so the moon's composition is basically a combination of the object that hit the Earth and debris from the Earth's mantle.
Now, if the moon came out of the Earth, that means the chemical composition of the moon, as you mentioned, should be similar, not exact, but similar to that of the Earth. Now, some people want to do mining operations on the moon, but if that's true, if the moon is very similar to the Earth, then perhaps there's no necessity to set up mining operations on the moon other than to build lunar structures on the moon itself. But to bring minerals back to the Earth would be a waste of money. But, well, what are your thoughts?
Well, that makes sense, Michio. That is certainly true. Now, one thing that we might do, though, is, there are asteroids out there, and the asteroids have materials that might be valuable because there are certain elements that are very valuable, like gold, for example, that are what are called siderophiles. That means iron-loving, and they sank out of the Earth's crust and mantle and into the iron core. And so if we could mine an asteroid, we actually might be able to find very valuable materials like gold and platinum and so forth that are rare in the Earth's crust, and they're rare simply because they sank out of the Earth's crust and became part of the iron core. So mining objects in space may make sense if we mine asteroids. Mining material on the moon, as you point out, may not make such sense, except, of course, to do as you say, namely to use that material for building structures on the moon. In fact, that would probably be a cheaper way to do it than to bring material all the way from Earth, because every time you launch stuff from Earth, you are fighting the Earth's gravity, and it's very expensive to transport anything off of Earth. So the more that we can get from the moon itself to help the people on the moon, the better. It's just going to be a lot cheaper.
Now, you mentioned that the moon is unusually large. Now, some people think that that is a very lucky accident, because if you take Newton's laws of motion and you take the spinning Earth and you simply fast forward the motion of a spinning Earth over hundreds of millions to billions of years, then the Earth would tumble. The Earth would eventually wobble like a spinning top that's winding down and flip over. So what keeps us in a confined direction, pointing, our axis pointing at Polaris, is a large moon. So without a large moon, the Earth would have tumbled, and that means that Mars probably already did tumble in the past, because Mars has no large moon. To Science Fantastic with Professor Michio Kaku. Today we're going to take a journey through the solar system. NASA is back in town again. NASA is once again exploring outer space with manned missions, perhaps to the moon in the year 2024, perhaps to Mars after 2030. So maybe NASA is no longer the agency to nowhere. But let's talk about the moon. If we go back to the moon in 2024, what are we going to find? With us today is astronomer Ken Croswell of Berkeley. When we last left off, we were talking about the fact that our moon is unusual. Take a look at Mars. Mars has two tiny moons. We have a gigantic moon. And some people think that according to Newton's laws of gravity, if you simply fast forward the spin of the Earth billions of years into the future, the Earth would eventually tumble, wobble, and tumble, making life impossible. So that means that Mars might have tumbled in the past. Same thing with Venus. So what are your thoughts about the fact that it's a good thing that we have a large moon?
It's a very good thing that we have a large moon. It is entirely possible we wouldn't be here if we didn't have a large moon. Now, this is one of the fascinating things that in the very far future we may actually be able to test scientifically if someday we discover life on other planets. We can see, well, do those life-bearing planets have big moons too, or are they like Mars, having nothing but small moons? Now, here's the thing about the Earth. The Earth's axial tilt is tilted 23.4 degrees from the vertical. And that position is fairly stable. It does change a little bit by 1 or so degrees over the years, but it doesn't change much. And the reason is exactly the reason you mentioned, that the large moon, the gravitational pull of the large moon that we have, keeps that axis at around that tilt. As a result, we don't experience the sort of climate extremes that Mars does. Because Mars right now happens to have an axial tilt that is very similar to Earth's. It's 25.2 degrees tilted from the vertical. But because Mars has only 2 small moons, Phobos and Deimos are their names, the axial tilt of Mars ranges all the way from 0 degrees to something like 60 degrees as the sun and the planets of our solar system tug on Mars. So some people think, and I don't know if this is true, nobody knows if this is true, but some people think that even though in the past Mars was a warmer and wetter planet, that perhaps one reason that Mars went bad is simply because its axial tilt changed so much over time, and it subjected the planet to climate extremes. So obviously, a planet that is not tilted at all is going to have a different climate from a planet that's tilted 60 degrees, as Mars is at its most extreme. So it is indeed a good thing for us that we have this large moon. And there's a second benefit to this large moon, and that is it may have encouraged life to migrate from the seas to the land, because the moon in the past was much closer to the Earth than it is today. The tides stirred up by the moon, by its gravity, were much greater in the distant past, and that may have encouraged life, which we think started in the seas, to migrate onto land. And, of course, here we are now. We are land creatures, not dwelling in the ocean.
Now, when you think of the moon, right now, think of the moon. It's the same man in the moon. In Asia, they call it the rabbit in the moon, but it's the same man in the moon. It never changes. In other words, it's locked, tightly locked to the planet Earth. So one day on the moon is 30 Earth days. So explain how that works. Explain how the fact that nobody has ever seen the other side of the moon until the Russians sent the space probe to the backside of the moon, freaking out the United States space program because we were clueless about what the backside of the moon looks like. Could you explain?
Yes, the moon has basically had its spin synchronized with its orbit as a result of the Earth's gravity. So the moon actually does spin, but it spins at exactly the same rate as it orbits the sun. It takes the moon about a month to orbit, as it orbits the Earth. As the moon orbits the Earth, it spins, but at exactly the same rate. So it takes the moon about a month to orbit the Earth, and it also takes the moon about a month to spin once. And so we here on Earth always see the same side of the moon. And the far side of the moon, which you mentioned, is actually quite different from the near side. The near side has these large, what are called maria, that are smooth volcanic plains. And the back side of the moon is much more heavily cratered. So it was quite a surprise when we first saw the back side of the moon and discovered it was quite different from the near side.
And during the Middle Ages, some people in a monastery wrote down that there was fire on the moon, that there were flames coming out from the backside of the moon, smoke coming out, and they wrote all the details down in their diary, and then people forgot about it for 1,000 years or so. But however, some astronomers, paleo astronomers, are looking back at that incident, and they think that there's a crater a crater on the backside of the moon, which is the site of the impact of what happened in human lifespans. That is, during the Middle Ages, perhaps there was a meteor which slammed into the backside of the moon. But what do you thought? Do you think that was just somebody tripping out during the Middle Ages? Or you think that perhaps they did record a celestial impact?
It's certainly possible. We know that object hits other objects in our solar system rather frequently. You may remember in 1994, a comet hit the giant planet Jupiter. And we all watched as that comet got shredded by Jupiter's gravity, but also as that comet scarred Jupiter. So we saw that in our lifetime. It's certainly possible that these people did observe an asteroid smashing into the moon. Just take one look at the moon, you see all those craters. You know it's suffered a lot during its 4.5 billion year lifetime.
Now, also it was announced that there's water on the moon. Now, at first I thought, come on, give me a break, right? I mean, water on the moon? The moon is baked by all that radiation from the sun. But apparently there are shadows, permanent shadows of gigantic mountains on the moon, and you can have water, ice being formed in the shadows. But what are your thoughts? So what is the latest concerning whether or not maybe one day our astronauts would be able to use water on the moon?
Yes, as you point out, especially at the south pole of the moon, there are these permanently shadowed craters that can protect water ice from sunlight. And so you can have water ice there. By the way, there's also water ice on the planet Mercury, which is perhaps the last place you would expect to find water ice. But again, it's at the poles of that planet in the floors of of craters that are shadowed from the sunlight. So yes, it is certainly possible the moon has that water ice. Now, the reason, by the way, the fundamental reason that we think the moon is so dry, though, goes back to your very first question. That is the formation of the moon, because the formation of the moon was so violent, and it must, as that object hit the Earth, it would have heated all of that material tremendously and boiled out any water. So overall, the moon is very dry, but the fact that there is water ice on the moon is obviously a very good thing for future astronauts, because, again, anything you can use that's right there on the moon is going to be a lot more cost-effective than having to lug water up from the Earth to the moon.
Okay, well, moving on, let's say a few things about Mars, because the President and NASA, they've stated that the goal is, well, yes, let's go back to the moon, but use the moon as a stepping stone to go on to Mars. Now, when we photograph the surface of Mars, we see riverbeds. We see the remnants, perhaps, of seas, maybe even an ocean, ancient water on Mars, which once flowed freely. So here's the mystery, and the mystery is that once Mars had a more tropical environment with water, where did it go? What is the latest understanding of where the water on Mars went? Welcome back to Science Fantastic with Professor Michio Kaku. And so there's a mystery about Mars. Mars is not what we thought it was. We thought it was just a barren desert. Not much evidence of life as we know it, but once upon a time, it had a more tropical environment, and we see riverbeds, the remnants of seas, maybe even an ancient ocean on Mars. And the question is, where did the water go? So, Ken, what is the latest concerning what happened to Mars?
Well, first of all, I would caution you on using the word tropical to describe ancient Mars. It is entirely possible that even though we do believe that Mars was warmer and wetter in the distant past, by which I mean some 4 billion years ago, it's possible it was never much better than modern Antarctica. So in other words, Mars may always have been quite a bit on the cold side, which kind of makes sense. It's 52% farther from the sun than the Earth is. So we actually don't know exactly how warm and wet Mars was at its very best 4 billion years ago. But you are absolutely right that we do see dried up river beds on Mars. We see what look to be dried up lake beds on Mars. And so it does appear from the evidence on the Martian surface that Mars was indeed a warmer and wetter world 4 billion years ago. Whether that means it was tropical, I kind of doubt. Whether that means it was more like Antarctica, that's definitely a possibility, but it was better. So you ask the question, well, what went wrong? Where did the water go? And it all seems like it's tied to this basic fact that the ancient Martian atmosphere was a good deal thicker than it is today. That the atmosphere on Mars right now is very thin. It's less, the surface pressure is less than 1% that here onto the Earth. But back in the old days, the very old days, some 4 billion years ago, Mars had a thicker atmosphere. It presumably had a greenhouse effect, just as we do here on Earth. In fact, it's the greenhouse effect here on Earth that raises the temperature on the Earth so that it's a pleasant world. Without the greenhouse effect on Earth, the Earth would be an ice-covered planet. And in the distant past, we think that Mars had a thicker atmosphere and that this warmed up the planet and allowed rivers to flow perhaps continually or perhaps just occasionally. It could be just a day or two a year. But somehow Mars lost its atmosphere, and that's the thing we'd like to understand better. What is it that made Mars lose its atmosphere? Was it because Mars lost its magnetic field and the solar wind then tore away the atmosphere? Is it possible something hit Mars and tore away the atmosphere? Or is it simply that Mars is a smaller planet than the Earth, and the volcanoes on Mars, which we do see, simply stopped erupting gas into the atmosphere? So these are all questions we have. But the big question, why did Mars go from being a, shall we say, better planet to being the bad planet it is today? We don't have a full answer to that yet.
Welcome back to Science Fantastic with Professor Michio Kaku. The theme of today's program is, NASA is no longer the agency to nowhere. We are going places. Prices have dropped. The recent shuttle launch was a success. The booster rocket for that Falcon 9 rocket was a reusable booster rocket. And some people think that's going to drop the cost of space travel by a factor of 2, maybe even 10. Right now, it costs $85 million for just one seat on the Russian Soyuz space capsule. We are hitchhiking on the Russians at $85 million a pop. Some people are saying that we can drop that by a factor of 10 if we have our own reusable booster rockets launched from Cape Canaveral. But with us today to talk about all these things is Dr. Ken Croswell, astronomer at Berkeley, author of the book Alchemy of the Heavens. Where we last left off, we were talking about the fact that, there's a mystery. Mars, once upon a time, had liquid water, seas, rivers, we think, but they're all gone. Where did they go? Well, there's one theory that says that, Mars is farther away from the sun than the Earth, so when the Earth was still molten, Mars began to cool down, and maybe there was, in fact, liquid water seas where life got off the ground. And then a meteor perhaps plowed into Mars back then, and maybe life, DNA, formed in those ancient seas, which were then blasted into outer space by a meteor, which then landed on the Earth, seeding the Earth. In fact, some astronomers have said that the solar system was perhaps like a ping pong game, with meteors going back and forth between Earth, Moon, Venus, Mars, maybe, just maybe, carrying DNA along with it. Now, when I first heard this theory, I thought it was kind of harebrained, but since then, several astronomers have said they're looking at this scenario rather seriously. But what are your thoughts about the fact that, who knows, maybe life started on Mars first, seeded the Earth, and we are the Martians? What are your thoughts?
Well, it's certainly possible. We know that in the early solar system especially, there were a lot of asteroids roaming around and smashing into the various planets, kicking up debris. Mars is a smaller planet than the Earth is, therefore it's easier to kick debris off of Mars and send it into space than it is off of Earth. Nevertheless, the fact is the Earth is a pretty big place. We know it has oceans, and it had oceans a long, long time ago. I don't see any reason why Earth life had to have arisen elsewhere. It could have arisen right here on Earth, because we know we have the right conditions here on Earth. I also don't quite get how we would ever prove this idea that actually life first arose on Mars and then got transferred to Earth. I think that would be a major difficulty with this hypothesis.
Well, I think the only way to prove the hypothesis is to go to Mars with our robotic space probes or with humans, grab some Martian soil and cross your fingers, hope that they find evidence of organic chemicals and maybe precursors of DNA. Speaking of which, what about life on Mars? Have we found any evidence whatsoever, besides certain organic chemicals that are consistent with life? Have we found the smoking gun, any evidence at all of microbial life or any form of life on Mars, or at the present time, is it simply barren?
Mars, as far as we can tell, is barren at the present time. Whether it was barren in the distant past is an open question. And indeed, if Mars did give rise to life some ancient time, we might be able to find fossils of that life in the oldest parts of Mars. But right now, there is no smoking gun for life on Mars.
Okay, now let's say our astronauts do go to Mars sometime after 2030. What are the hazards that they face? I mean, we have a protective atmosphere that shields us from cosmic rays and stuff like that. It gives us life-nourishing oxygen. But what are some of the hazards that our astronauts face on Mars? Temperature, atmospheric density, presence or lack of liquid water. What are your thoughts?
Well, one of the problems is the atmosphere itself has almost no oxygen. It's made almost entirely of carbon dioxide, which, of course, is the gas that we breathe out. The temperature is quite unpleasant, and there are other problems as well.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, our special guest today is Dr. Ken Croswell. Well, Ken, we were talking about Mars, the fact that, well, we don't see any signs of life on Mars, but hey, we'll probably go there sometime after 2030. But what lies now beyond Mars? Recently, you wrote an article about Uranus and Neptune. Now, the ancients knew about Mercury, Venus, Earth, Mars, Jupiter, Saturn. They knew about those planets. They did not know about Uranus and Neptune. So tell us a little bit about those planets which don't get the limelight as much, of course, as the planets out to Saturn. But tell us about Uranus and Neptune in your article.
Yes, Uranus and Neptune are two of my favorite planets. And as you correctly point out, they don't get much limelight. All these other planets get a lot more attention. And so in the December 2019 issue of Sky and Telescope, the cover story is all about those two planets, what we know about them and what we don't know about them. We have only ever sent one spacecraft to those planets. That's Voyager 2, which passed the planet Uranus in 1986 and Neptune in 1989. And we'd love to send a second spacecraft. And in particular, we'd really like to put a spacecraft into orbit around one into orbit around the planet Uranus and the other into orbit around the planet Neptune. Because the nice thing about an orbiting spacecraft is it gives you a prolonged view of the planet and its moons, as opposed to a flyby, which gives you just a few days glimpse at a planet. And so there's a lot to learn about these two planets. And what we also know now that we did not know in the 1980s is that there are a lot of other planets out there going around other stars that have about the same diameter as the planets Uranus and Neptune, both of which are about 4 times the diameter of the Earth. So they are smaller than Jupiter and Saturn. Jupiter and Saturn are gas giant planets made primarily of hydrogen and helium that their gravity squeezes into a metallic fluid. In the case of Uranus and Neptune, though, those planets are ice giants. They're made primarily, we think, of water ice and other ices, such as methane and ammonia. And the atmosphere, which is made primarily of hydrogen and helium, only constitutes a fraction of the planet. But it looks like planets like Uranus and Neptune are very common in the galaxy. And so that's another good reason to send second spacecraft to those two planets to learn more about them.
Now, when I was in elementary school, we learned about the solar system, that there are rocky planets, Mercury, Venus, Earth, Mars, and then out far away we have gas giants like Jupiter, Saturn. But now that we've discovered 4,000 exoplanets orbiting other stars, we have to get rid of this old-fashioned view that we used to have of planets, mainly rocky planets, in circular orbits around the mother star. We now realize that most planetary orbits are not like our solar system, and Neptune-like planets are quite common throughout the universe, more common than perhaps rocky planets. So tell us a little bit about how the discovery of 4,000 solar systems out there and planets have revised our old-fashioned view of the solar system that we learned when we were in elementary school.
Well, there's nothing like having actual observational data to shake up your view of things. Because in the old days, yes, we thought that we would have rocky planets close to a star, akin to Mercury, Venus, Earth, and Mars, and then giant planets far from the star, Jupiter, Saturn, Uranus, and Neptune, and then smaller planets beyond, like Pluto and Eris. Well, we don't necessarily find that in other solar systems. Sometimes we find that there are giant planets very close to a star. That was our discovery in 1995, a complete shock around a star called 51 Pegasi. And we're also discovering a type of planet that doesn't even exist in our solar system. There's a big gap. If you were to rank our planets in our solar system by size, you put Jupiter first, and then Saturn, then Uranus, then Neptune, then there'd be a big gap. And then you'd go to Earth and Venus and so forth. But there's this big gap between Neptune, which is the smallest giant planet, and the Earth, which is the largest small planet. And it turns out that there are many planets out there going around other stars that are in that gap. And we call many of these planets super Earth. In other words, they're bigger than the Earth, but they're smaller than Neptune. That's a type of planet that we didn't even know existed because it does not exist in our solar system. So there's all sorts of things going on in other solar systems that we don't see in our own, and that's one of the reasons, of course, that we like to explore these other solar systems as we continue to seek a planet that is like the Earth, because that's probably the ultimate goal of many astronomers interested in other solar systems, is finding a life-bearing planet with pleasant climate, nice atmosphere, water, all those good things that we take for granted here on Earth.
Now, the holy grail of this search for planets orbiting other stars is to find a twin of the Earth. But as I understand, so far we have not found it. We've come very close. We've seen planets that are roughly the size of the Earth, but maybe they're orbiting a star that's unstable. Or for some reason, there's reason to doubt that they can sustain life, especially life with a temperature comparable to temperatures found on the planet Earth. So what's the status? What's the status so far of finding a twin of the Earth in outer space? Are we close?
We have not yet found an exact twin of the Earth in space. We have found planets that are about the size and mass of the Earth, but we have certainly not found anything that we can say, yes, you can move there today.
Okay, well, unfortunately, we have run out of time. So, Ken, once again, thank you so much for being on Science Fantastic.
Glad to be here. Thank you.
Good day.